This is Josh White with JW Math Tutoring, and this video is going to focus on the digital SAT practice test number 3 from the Bluebook app, the Math Module 1. So let's go ahead and get started.
But life is a dream that calculus could never predict.
All right, just before I get started with Module 1 from Bluebook, Digital SAT Practice Test number 3, Math section, of course. I just want to remind you of a couple things. First of all, I like to show as many methods as possible when solving some of these problems. So because of that, most likely I will go past the allotted time that you would have to complete this specific module. But of course, keep in mind, if you're taking this test as an official test, of course, you wouldn't be doing, some of these problems 2 or 3 different ways unless you, were really stuck on it or had extra time left at the end. And the second thing, of course, if you like this video, please do give it a thumbs up and subscribe to my channel and sign up for notifications as well. All right, so now let's go ahead and get started. We've got a bus traveling at a constant speed. They give us the equation for the bus, and they just want to know basically what the feet will be 2 seconds after passing this marker. So really all you're doing here is you're just plugging in 2 for t, and that just tells us that d is going to equal 60. So correct answer for this is letter C. That's it, and we can just move on. All right, now they give us the slope of this line and they give us the point it passes through. Note that this point it passes through is the y-intercept, even though they don't tell us that because the x coordinate is 0. So b has to be 14. Therefore, the equation line is just going to be y equals 1/9, the slope, x plus 14. So correct answer is letter D. Now, just to show you this, and this is mainly to use for more difficult questions, but if you were given a slope and given a point and it wasn't the y-intercept, or whatever, you're still having difficulty with this, what you could do is you could just go into Desmos and you could just go ahead, add a table, put the point in the table, and then we just do a linear regression like this, and we're going to put the slope in. And then it just tells us b is 14, so obviously it's going to be 1/9 x plus 14, or letter D. All right, next, here you have a proportion. It's basically an equation. They're asking you what the value of 8 over x is. So a couple different things. First of all, if you know properties of proportions, okay, so x over 8 is equal to 5, but you could also write that as 5 over 1. So one property of proportions is you can just flip both sides and the equation will still be true. In other words, 8 over x is just going to be equal to 1/5. So the correct answer for this, you could grid in 1 divided by 5. You could also grid in the decimal equivalent, which would be 0.2. However, if you didn't know that, that's fine. Just go ahead and solve the equation and get, x equal to 40, and then 8 divided by x, well, 8 divided by 40, and you would notice that reduces to 1 over 5, or if you just do it in Desmos, it'll give you 0.2, and then you could grid that in. Okay, so either way, these are the correct answers. Next up, we have 2 triangles which you're told are congruent, and they're both right triangles. So I'm just going to draw a quick sketch of them here. Okay, so we've got ABC and DEF, and it tells us that B and E are the right angles. That means B has to be down here, and it also means E has to be here, and A corresponds to D, and therefore C must also correspond to F. All right, so now we know A is 18 degrees. What is the measure of angle F? So all we have to know here, figure out, is that C is going to be 72 degrees. It's basically 90 degrees minus 18 degrees. And since C corresponds to F, F will also have to be 72 degrees. So correct answer on this one is going to be B. You could also have looked at it the following way. You could also have said, okay, A is 18 degrees. Since A corresponds to D, corresponding parts of congruent triangles are congruent. This is also 18. And then over in this triangle, you could have just done 90 minus 18 and gotten 72. So either way you think about it, correct answer is B, 72. All right, now here you have two expressions that are being multiplied, and they want to know which one they are equivalent. The one answer choice is equivalent to this. So if you know the rules of exponents, you should hopefully recognize that m to the fourth times m is just going to be m to the fifth. Q to the fourth times q to the fifth, q to the ninth, because we add exponents, and z to the negative 1 times z to the third will be z to the second. So the correct answer for this one is going to be letter B. Now, technically, you could also do this one in Desmos. You just have to add some sliders. So here's how you could do that. First thing we have to do is type the original expression and I'm going to add sliders for all. Just keep them all as one for right now. And now you got to put in the second part of it. All right. So here's the thing. You can make these values whatever you want. Um, so let's say maybe like whatever. Move this to 2, move this to 2, whatever. Move this to 3. Numbers are still pretty gigantic, so whatever. I'll make one of them 1. Okay, there we go. All right, perfect. Now what you would do is you would go through the answer choices. You would type in each answer choice, and you would see for these values, do you get 2177.1435? I'm not going to go through all of them, but I will confirm that for B, if we type that one in, execute a knife, Z to the second. Oh, there's an error in how this was typed in. I did the same thing up here. Get rid of this. Sorry, this should be Z to the negative 1. Okay, now it's typed in correctly. Now we have normal whole number values like we should. All right, so notice 4608, 4608, it matches. Okay, that's what confirms that that the original given expression is matching with answer choice B. And you could type in the others just to confirm that they don't equal, but you can use Desmos to match equivalent expressions. All right, here we have a box plot. So they have questions here, the answer choices here, excuse me, about comparing the mean and the median from these two things. So technically, you cannot get the mean from a box plot because you don't know how the specific values are broken down. You just know kind of like where the specific cutoffs are for like the lowest 25%, lowest quartile, middle quartile, upper whatever 50%, upper 75, or 25%, and so on. So we're not going to be able to compare the mean. So these two are out right away. Basically, we're comparing C and D. And so if you look here, the line in the middle of the box, so for example, that line right there, this line right here, that is the median of the set of data. So clearly we can see here the median for group 1 is greater than the median for group 2. 25 right here is greater than 24. So the correct answer for this is letter C, and that's it. Here we have a system of equations. Quickest, easiest way to solve this is just go straight to Desmos. However, I will show the mathematical way after that. So we go to Desmos. We'll just clear out all this previous stuff we were working on. Graph the first line, which is just going to be a horizontal line. And now on the second one, Okay, and these two, it tells us these two intersect at a point. What's the x coordinate of that point? Okay, so we got to scroll up here. I'll zoom out. All right, so it looks like they intersect at 976 or negative 976. So the two possible answers looking for positive 9 or negative 9. We only see one of them in the answer choices. So correct answer is going to be negative 9 right here. Now, here's how you could actually solve this algebraically. Just do substitution. Replace the y in the second equation with 76, and then solve that quadratic equation for x. Add 5 to both sides. 81 equals x squared. Square root both sides. Don't forget the plus minus. X equals plus or minus 9. And again, you would look up in the answer choices. Do I see positive 9? Do I see negative 9? I only see negative 9, so that's the correct answer. All right, the next one, number 8 here, deals with basically um, properties of surveys, specifically related to like margin of error. And so essentially, the mean that you get of whatever you're measuring, which in this case they're talking about the proportion of the population that has this characteristic, whatever is 0.49 or 49%. Um, the margin of error tells you kind of the range of the values that you actually expect the true mean to be in. So in other words, you take what you measure for the mean, in this case 0.49, and you add to that the margin of error, the 0.04, and then you also subtract from it on the other end the margin of error, the 0.04. So the conclusion that you can draw is letter A here. It's basically plausible or expected that the proportion of the population that has this characteristic is between 0.45 and 0.53, i.e. 45 to 53%. That's what you expect the actual true mean to be between those numbers. Again, the measured value plus the margin of error minus the margin of error, and that gives you your range. Here we have another system of equations. So easiest way to do this one is, again, go straight to Desmos, graph out both of the equations, and just see how many times do they intersect. So now go back down. Okay, it looks like it is 0 because we have some parallel lines here. And hopefully you recognize that's the case because, so correct answer again here is 0, letter A. Because notice they have the same slope but different intercepts. So if you tried to solve this equation, so let's say instead of graphing it, you tried to solve it out, notice you end up with 0 equals, excuse me, not 0, it's 0x, but sorry, 10 equals negative 1, because the two x's would cancel out on both sides. This is never true. There's no value of x which makes this true. Therefore, this is no solution. So at how many points do they intersect? None, or 0. All right, for number 10, we have another question that can be solved using Desmos and the calculator. So basically, you're told it's a linear function, so it's a line, and it contains these 2 points. So what's the equation of it? Well, let's just jump back here to Desmos. Let's make a table. Let's put both of those points in the table. Then let's do a linear regression. That'll give us the slope. That'll give us the y-intercept, which will give us the answer. So it looks like the slope is 4. The y-intercept is 2. Therefore, correct answer is going to be letter C here. F of x equals 4x plus 2. Now, just to confirm, if you actually do this out by hand, getting the slope, you're going to do 34 minus 2 over 8 minus 0. That gives you 32 over 8, or 4. And then notice here, this is already the y-intercept value, so we could just plug it right in. You don't need to solve for b because we already have b. B is 2. So that just confirms correct answer is letter C. All right, next up, problem number 11. Here you have basically an equation or proportion with x and y in it, and they want to know what the value of n has to equal based on this second proportion. So unfortunately, this one is not a multiple choice. Um, Otherwise, you could back solve it. But since it's a student-produced response, okay. If you take 24x over ny, notice that x over y, so you kind of like if you block off this thing, has to equal 4. So in other words, if I just replace this with a 4, I've got 24 times 4 over n equals 4. In other words, 96 over n equals 4. And now you could go ahead and just cross multiply. 96 equals 4n, and then divide by 4 on both sides. You probably already recognize n has to equal 24. And that's the correct answer. And if you notice that up here originally in the first step, like these 4's basically cancel out. So then this would really just be left with a 1. So it's like 24 divided by what is 1? Well, just 24, same number. So if you recognize it from that point, that's fine. That's good. Just 24 is your answer, and move on to the next question. All right, now for problem number 12, here you have another linear function, but all they're really asking is essentially what is basically the answer to this is coming from the slope. There's this function is telling you how much liquid is left t seconds after you start draining it out. So at like 10 seconds, you plug in 10 for t, and whatever number you get, that's how much liquid is left. So notice 4 right here is your slope. Technically, it's negative 4 because it's reducing the amount of liquid. But they say here, according to the model, what is the predicted volume draining each second? So the answer to this is just 4. In other words, it's just how much is the volume in the container reducing by after each second. And you just notice that, well, it's going down by 4. Now, if you weren't sure of that, if you just whatever couldn't figure that out, didn't make sense to you, you could also do picking numbers on this. You could say, okay, when t equals 1, how much liquid's in the container? Okay, when t equals 2, how much liquid's in the container? So you just plug those in. When t is 1, 300 minus 4, there's 296. When t is 2, plug it in, there's 292 milliliters. So how much was drained in the 1 second from t equals 1 to t equals 2? Well, 4 milliliters. So that's how you could also confirm your answer using, again, the strategy of picking numbers. All right, next up we have number 13. This deals with an exponential, basically a function. So this investment is increasing by 0.49% of its value from the previous year, and which describes this. First of all, it's increasing, so get rid of the two decreasing answers. Those contradict, the information that you're given. Now, the reason it's increasing exponential is because it's increasing by a percentage. Increasing linear functions are those which increase by a specific value or amount. Okay, so this one, because it's increasing by a percentage, that's what makes it exponential. All right, here we have another system of linear equations. So the easiest way to do this, just go back to Desmos, punch in both the equations, look for the intersection point. If yeah, there is one because they ask us to find it. Okay, they want to know the value of y. So let's zoom out here. Okay, looks like it's going to be up here, just to the left of the y-axis. Looks like it locks in right here at negative 1.333 or negative 4/3, 80. So correct answer is just 80. And that's it. That's all you have to do for this. But I will show you just real quick if you wanted to solve this out, algebraically or double check it, I would multiply the bottom one by -4, and that would give me negative 24x minus 4y equals negative 288. And then if you add down each column, 24x cancel. Y minus 4y, negative 3y. 48 minus 288, negative 240. Divide by negative 3. Y equals 80. Same answer that we got, just by graphing them out in Desmos. All right, next up, we've got a quadratic function. Where does the minimum of this function occur? Okay, so again, quickest, easiest way, we go to Desmos, we graph it out. We just look for the vertex on the graph, which will be the minimum point. So now we'll have to zoom back out, scroll back down. All right, so this one, it wants the x-coordinate value, not the y-coordinate. So, okay, it locks in here 7, negative 27. So for what value does it reach the minimum? Well, it is just 7. So that's the correct answer. Now, alternate way you could do this, you can use the formula negative b over 2a. That's for the h or x-coordinate of your quadratic function. So you could just do the opposite of negative 14 over 2 times 1. 14 divided by 2, positive 7. Same answer. Doesn't take that much longer than graphing it, but that's another method you could use as well. All right, for this function, we have a line, and we're also, they're asked about its x and y intercepts, and they want to know what's the value basically of adding them together. So again, we're going to go back to Desmos. We're going to graph this line. We're just going to grab the values from it. So it looks like the x-intercept, or a, is negative 7. And the y-intercept locks in at 28. So if we multiply those together, oh, we're not multiplying, excuse me, we're adding. So we add those together, we get positive 21. So the correct answer for this one should be letter A, 21. Now, a couple things. Notice this is in slope-intercept form, so we actually already know that B is 28. And now for the x-intercept, if you were to solve it out, you would just basically replace the h of x with 0 and then go ahead and solve. So you just subtract negative 28 and you get 4x equals negative 28, and you divide by 4 and you get x equals negative 7. And then lastly, add them together. Negative 7 plus 28 is 21. Same answer I got from Desmos, but it takes a little bit longer. It's a little more work, but it's, it works as well. Next up, number 17, we have this square, and it has side lengths that are 160 times the lengths of another square. But it tells us the area is k times the area of the other one. So what's the value of k? So the shortcut way to do this one is just to notice that, like, when we're talking about an area, since it's two-dimensional, since each side is 166 times, the length of the other square, area is just going to be that, like, scale factor, the 166 squared. Okay, and that's 27,556. The reason is because you have to do the 166 times, scale factor for both the length and the width. Now, if you don't know that, that didn't come to you intuitively, that's fine. Let's use the strategy of picking numbers. Say that square A, or actually, would say square B start off its sides as 1, 1, 1, 1. Okay? And then A, which is 166 times that, is 166, 166, 166, blah, 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 166. So what's the area of square B? Well, it's just 1 times 1, it's 1. What's the area of square A? Well, 166 squared, which is 27,556. The area of square A is k times the area of square B. Okay, so this area is equal to the area of B times k. So what does k have to be? Well, k, that's equal to the 27,556, that I mentioned earlier. Next up, question number 18. Here you basically have a bunch of points, you scatter plot, and there's a line of best fit shown. And they just want to know what is the predicted y value when x is 25 and a half. So we're just looking on the graph here, 25 halfway between that and 26. We go up. It looks like it's about right here. So it's like between 8 and 9, a little closer to 8. So 8.2 is the only one, letter C, that makes sense because there's nothing else that's between 8 and 9. So that's all to do for this question. Nothing else. Now, question 19. Here you have some angles that are in radians, and basically you're just adding these together and then going to convert them to degrees. So you can do the adding by hand, or of course you can go to uh, Desmos and just do it in there, but it's basically 2 pi over 3 plus 5 pi over 12. So if you just multiply the first angle by 4, it becomes 8 pi over 12. You add that to the 5 pi over 12, and you get 13 pi over 12. And then to convert that to number of degrees, you can just take that and you can just go ahead and multiply by the conversion factor, which is 180 degrees is equal to pi radians. So we can go ahead and cancel out the pi's, and then 13 over 12, 12 goes into 180 15 times, 13 times 15, it comes out to 195. So correct answer is letter C, 195 degrees. But again, all this work could just be done just straight in Desmos. 2 pi over 3 plus 5 pi over 12, and then whatever you get for that, and then times 180 over pi. And it will give you 195. Now we have an exponential function here for number 20. And basically you start with 12,000 these bacteria, and then it tells us, okay, 4 hours later it's going up to 24,000, and they give you the basic form of the function or the equation here. You want to know what the value of r is. So if you're going to do this, so first let's just show you, you're going to do it by hand, or kind of like the theory behind it, right? It's p equals c 2 to the rt. So t is your number at whatever time you're specifying. So in this case, our time would be 4 hours, and that would correspond to 24,000. And then c is the initial amount or initial quantity. So that would be 12,000. And then you could just go ahead and basically note that you divide both sides by 12,000. It comes out to 2. So you've got 2 equals 2 to the 4r. And now this is a very simple, easy equation to solve because on the left side it's just, 2 to the first. So therefore you just match up the exponents. 1 is equal to 4r, and then divide by 4. R is equal to 1/4. So correct answer for this one is going to be letter B. Now you could also do this one, let's see, using back solving, or in relation to that using Desmos as well. So let me just clear the screen here. Remember, this is the correct answer we're looking for. So let's see. All you'd have to do is basically go through the answer choices, and obviously going to be much quicker to do this in Desmos, but essentially what you're plugging in would be 12,000 times 2. Let's say you start with the first answer choice, 1 over 12,000 times 4. And we do that in Desmos, and you're going to see, does that equal 24,000? Does that give us 24,000 bacteria, 4 hours later? The answer is no, and then you would move on to answer choice B, and then you would plug in the same thing, except this would be 1 over 4. So, I'll just show you that real quick to confirm, and then I'll also show you another way you could do it in Desmos as well. So, like I said, you got 12,000, and then 2, and now here, yeah, we got 1 over 12,000 in the exponent. Remember not to type the commas. And then this is multiplied by 4. Okay, so see, this whole expression should come out to 24,000 because after 4 hours, there are 24,000 bacteria, but it doesn't. So that tells us it's wrong. So now you could go to answer choice B and just change this to 1 over 4. Okay, now it gives us 24,000. That's the correct answer. Again, this is the idea of back solving, basically plugging in the answer choices to the problem and seeing which one works. Now, um, you could also, I suppose, do the same thing where like you graph out the function by just plugging in the answer choice for R and nothing for T, and then trace along the graph to find when T is equal to 4, which graph gives you, which graph has a Y value of 24,000. But because the numbers, so in other words, what I'm saying is, it wouldn't, it's not a, probably a good idea for this problem, but just in general. So if you have this, we'll just use X. Yes, 1/4 X. All right. See, the graph wasn't even visible there because it like goes, goes up so sharply. So now, technically, what you would do is you'd have to like, basically scroll all the way up. You got to zoom out way here and then trace along the graph and see, okay, I want a value, whatever, way up here, and eventually you would get to. Yeah, see, it's going to take forever. It's going to be a gigantic pain to do because the numbers are so large. But eventually, you would see that if you could get it to where x is equal to 4, you would have a y value of 24,000 that would confirm it. Again, not a good choice for this specific problem, basically, like of graphing the answer choices out and then uh, seeing where the given x value, seeing what its y corresponding y coordinate is, but it's something that could be useful on another problem, that you come across later, which is similar. All right, now number 21. Here we have a radical equation. So first of all, I want to know a small solution. We can actually, again, we can do this all in Desmos. So I'll show you that method before doing it by hand. Zoom in so we get some smaller numbers here. All right, so all we have to do is basically just graph each side of this equation and see where they intersect. So there's the first one, there's the left, basically the left side, and now we have second one, the right side. Okay, now they're probably going to intersect. Yeah, see, they intersect at multiple spots. So there's 10, 8, and right here, -3, 5. So we obviously only want the x values. So which is the smallest one? Well, it's just -3. So that's it. Correct answer, -3. You can move on to the next question. Now, I will show you, just for information purposes, the way you would actually solve this out by hand, of course, is you would square both sides, and you'd get x minus 2 squared equals 3x plus 34. And then you could go ahead and you could FOIL this out, and it's going to be x squared minus 4x plus 4 equals 3x plus 34. Then you could bring the 3x over and it becomes x squared minus 7x. You could bring the 34 over, excuse me, so it's going to become -30. Now it's equal to 0. You can factor it, and you're going to get x minus 10, x plus 3 equals 0. So that gives us two answers, positive 10 and -3. What is the smallest solution? Well, obviously -3 is. So this is how you would actually solve the equation by hand. But again, there's no need to do that because you can just type both sides into Desmos, see where they intersect, take the smaller x value, and be done with the problem. All right, now last question on practice test 3, module 1. So here we have an equation. It wants to know which of the following are solutions to this, where a is a constant and a is greater than 30. So let's just try plugging some of these in and seeing what happens. So notice, actually, notice first, since we have the same term here on both sides, x minus 29, x minus 29, like in order for these to equal, that means the x minus a parenthesis here, or factor, if you want to think about it that way, has to equal 1. Because that's the only way you can get x minus 29 equal to x minus 29. If this entire parenthesis equals any number other than 1, then the two sides aren't equal. Then there's no solution. So x minus a has to equal 1. So what do we know about um, basically plugging, if you like look at plugging any of these answer choices in? So if you start with 1, if you plug in a for x, you get a minus a equals 1, or in other words, 0 equals 1. Is that correct? Is that true? No, it is not. So therefore, this cannot be a solution to the equation. What about the second one? So notice a plus 1 minus a, plugging this whole thing in for x, equals 1. Now here the a's cancel out and we get 1 equals 1. That is a true statement. So therefore, basically, if you think about it, if you plug that in up here, this whole thing would just become 1, and you would get x minus 29 equals x minus 29. Like, really, you're looking for the original equation that you're given to have the same number on both sides for one of these expressions to be a solution. So, and just to, sorry, back up one step. So if you think about that with the first answer choice, like if you plugged in a here, okay, a minus a basically just turns out to be 0. And on the right side, 0 times anything is 0. So you get x minus 29 equals 0, okay, which is not basically not correct or not true. Or actually, sorry, we would need to plug it in. Sorry, we need to plug in a for both of these things. So we would actually get a minus 29 equals 0. And then if you tried to solve that for a, notice you get a equals 29, but that does not meet the condition of the problem. The problem says a is greater than 30. So that's just further proof of why the first possibility is wrong. Now, we already confirmed that the second one is correct because basically if you would plug in a plus 1, then the a's cancel out and you just get essentially x minus 29 equals x minus 29. Okay, good. Now, let's look at the third one, which is 29. So one thing to keep in mind too is that since we already eliminated 1, we can actually know that the answer to this question is going to be C just by process of elimination. We don't actually have to confirm that 3 is true as well, but I'm still going to do it just to show you that it works out. All right, so now if you want to think about it in terms of, again, x minus a has to equal 1. So um, what we want to do now is plug in the 29 for x. And here we do want to look at the full original equation. So what you get on the left is 29 minus 29. Okay, on the right you have 29 minus a times 29 minus 29. So on the left side we get 0. Right side we get 29 minus a times, well, 0. So we get 0 equals 0. That is true. Therefore, this value is also a solution to the equation. So we have two solutions to this equation. A plus 1 is 1, 29 is 1, because when you plug them in, you get the exact same expression or the exact same number, if you want to think about it, on both sides of the equation. Not true for the first one. Okay, so like I said, this one, correct answer is letter C. That was Module 1 of Practice Test 3, the digital SAT in the Bluebook app. You have any questions or comments about this specific test, please do leave them below. Otherwise, be on the lookout for Module 2A from this Practice Test 3, the easier of the second module, and also Module 2B, which is the harder of the second module for this test.